Hello everyone, welcome to another stream. How are we doing? Hey there Chris, how you doing? Good to see you. Okay. Let's get open the Game of An engine. And what we'll be working in today. Yeah, that file, the GFX file, right, where we issue all those lovely UI draw commands. On the shaders file where we do all our lovely shader stuff. So, interesting stream today. Hey there, John the Ripper. It's been a while. How you been? Good to see you. So last stream, we got some stuff done. Isn't that amazing? I think I can show my Twitter actually. Get that up. It's a good one to have open because I start to post there after every stream now, which is good. I have a little thing going. So this is the UI saga, I guess. We initially started with just doing like little boxes and rounded boxes, circles. You see, it's lovely and anti-aliased. Did a little glyph and a texture. But then I was looking at the code, I was thinking that, so the texture only works on a rectangle and so does the glyph at this point. But I was thinking like we've just got the color and the shape combined into a single thing. So how about we can separate those things out and just do sign distance fields to give us the shape. And then we have a distance and we can use that to sort of color it in, but also texture as well. So then it brought to this, we did a draw, we went, because we spent ages in the low level stuff, the low level side of it, just like the shaders and everything. And then worked on a draw API. And this is basically a sign distance field virtual machine, if we want to describe it that way, where you can just describe a bunch of like little commands that run, and then you say finish, and that's one draw command or whatever. So you have a bunch of operations in a command, and then you say finish, and then you can just do the next one. So you can say like, hey, I got a shape and a box. Sorry, I've got a circle and a box, and that makes the shape. We're gonna join those two together with a union. So there's this, and then we can border it because it's a distance. We have a distance per pixel. We can just say, okay, where if you're 32 pixels close to the edge, then make it green. If not, make it purple. And so that was pretty sweet API. What's going on with SDF UIs right now, lol? Hello, bit of computer. Welcome, Bam. Got this right last time, but then I'm bugging up right now. Bambukia. Welcome back. Hey there, Employed. What do you mean? What's going on with SDF UIs right now? I don't know. I've been doing them. I've done it before when I did like a text editor, and we did a similar thing to this, but this time it's gonna be way better because I'm doing it with like, it's gonna actually be optimized. Bambuki. Okay, Bambukia. Okay, Bambuka. Bambuki. Alright, let's clear that. Solly, how you doing? Good morning. Yeah, I've been mentioning my Discords right now as well. Fair play. Fair play. Yeah, basically sign distance fields, they're powerful. Super powerful. And they're allowed to do like so many good things with them. To the point where we're even going to use them for clipping as well. It's going to be bananas. So that's what I want to do today. Oh yeah, so this is what we did last stream. So it's red because where it's black is basically the sort of bounds of the shape that you're drawing. So we can texture it. Ta-da! And you can do glyphs as well now. So we've got the glyphs back, got the textures back. We've even got soft unions, standard unions. Yeah, the reason why you want to do SDFs as well, right, is if you're doing a game, you want to do some like fantastic crazy looking AI. Sorry, UI. We're into too much AI stuff on the X's, you know. But yeah, you want to do some really like unique 2D drawing, and you can do that with SDFs pretty easily. You can construct whatever you want. So yeah, we added all these ops. We did a couple of new texturing operations as well. And today is where it's going to go crazy. We're going to be doing gradients to start off with. And then we're going to be doing, here we go, gradients, anti-aliasing, transforms, and clipping using sign distance fields. So I've done this one before, and I don't know if I can dig it up, but basically I was able to clip like with where is it? It might be really bad. Man, it was a long time ago I last did it. Here it is. Here's my last sign distance fields plate. So I've done it with text in my previous one. So when I was doing that sort of like the rendering system for that text editor, I was like, you know, just make everything SDFs and just do some really insane, so you could like do all that. But anyway, pretty jazzy. Yeah, there you go. So here's the clipping that we did before. So I did like a Mickey Mouse and logo in a way with like the clipping shapes, which is just a bit of fun. But yeah, it's very flexible that way. Yeah, so clipping, like the problem is like when you do UI, the clipping is kind of shared. It's not, you don't really have a clipping per, because like the idea is the clipping is like, sure, SDFs are basically clip. Define a clip, right, in a way, because you know if the distance is less than 0, then you're inside the shape. But the problem is not necessarily that. The problem is that you can have a bunch of, you can have like a scroll area, right? And the scroll area, when it goes off the page, right, imagine this is like off the page. You just have some text boxes down here or whatever, right? Obviously you'll try it, shouldn't really render these, but maybe that it goes like half off the page. And the idea is you need to make sure that, so your clipping box in this case would be like maybe this, you know, so this bottom bit doesn't get rendered. So your clipping shape is, it could be shared between different drawers, but also it is, yeah, the shape is just different. That's Milton. I don't know if it's using MGUI. Maybe. Probably. What is a sign distance field? It's pretty simple. Given a point and a shape, give me a distance to the edge. So we use the IQ's blog here, and it gives you a bunch of good formulas to do it. So you know, given a point relative from the center of the shape, and all you need is the radius for a circle. It gives you a distance to the edge, and with that you can do a lot. And it says positive if it's outside and negative if it's inside. And sign distance fields are like super powerful. Like in 3D as well, you can do really crazy stuff, but we're just doing them for 2D. So we've got all sorts. So we're going to be working on, what we're working on first? Oh yeah, gradients. So it's going to get the code up. So, oh, I got my root beer here. Good times. So there's two different types of gradients, right? There is well, in terms of what we can do. Well, in terms of what we want to implement, should I say. So I want to implement like a gradient. Gradient that is distance based. Color gradient based on distance, color gradient based on maybe so let's have a think about this. Where we go? Let's keep the game running. So you can have a distance from an edge, and you can do a gradient. So basically you can do like a border in a way. So it just gives you a gradient to the center, right? So there's that way of doing it, like a distance-based one. And the other one is obviously you can do it across the x-axis and the y-axis. But it doesn't have to be across. You can define the axis yourself, right? So you say distance axis, and you just do like dot products basically, and you can just do that, right? Probably. So let's try and get those done. Based on an angle, you could do. Yeah, so there's two ways of defining like that, right? Yeah, but then if you do an axis, you need to doing it along an axis. I'm just thinking of the maths operations, right? You'd need like I don't know, how would you do it across an axis? Sorry, across an angle, using an angle. Like if you might have to use I'll think about that one. I don't know, how would you do it though? Because I imagine you have like the bounding box, and you're saying do a gradient from top to bottom. You know, a vector works fine, and you can sort. But then obviously if you do it across like an angle, then that would mean you what would you use to do that? Because you can obviously use sine and cosine and convert that to an axis there. Yeah, but then you've just got yourself a vector anyway. Yeah, it's possible. So yeah, I could just do a vector. And then using that vector, you can define. I'm not sure actually what you do. Or just the angle, it depends. Yeah, on the user side. Yeah. See, it entirely depends, right? I've got to delete that code. It's the old one. Right, so let's encode these ones. Source UI. So doing the color gradient. Let's start with the distance one, obviously. Gradient distance. So you want like a color, and then you want the distance value. Wait, what do you want? You need two colors, right? So you need two colors, and then you need like at what distance. We need two. You need two distances, right? You need, where does color A? Yeah, it is, yeah, distance bounds, that's right. It's also single float instead of two. Or we can use FP16. Yeah. That makes sense. Yeah, so definitely be lighter on the upload. I don't know what I should do. So you've basically got like a sort of like an outer, yeah, outer color, inner color, right? But it's kind of opposite to the border one in a way. So maybe we should say inner and outer, right? And then you kind of want like a inner distance. I don't know, it feels a little weird. Hey Russell. How you doing? Welcome, welcome. And the other one was gradient axis, I guess. Or like, so you're doing a gradient across. Let's see if there's a good name for any of these. Radial gradient, right, and then you've got like a linear one. Right, so I guess we have a distance gradient, linear, maybe. And maybe radial as well, I guess. That ought to be good enough. Wait, what do they use to define these guys? Hey, they're not so red, how you doing? Tony's love CSS. How do you find this? It goes to the right. Unfortunately, doing OpenGL because I don't think I have the time to do Vulkan. Fantastic. Yeah, things are going good, man. Things are going good. Just starting on the gradients today. Hopefully, we get time to do something like this. Little crazy clipping, custom clipping for UI elements. But yeah, things are going good. Things are going good. Started work yesterday. you know, I thought I had to have had a lot of catch up, but I didn't really miss too much, so it was good. Just got the ball rolling yesterday, got a task finished today, so happy about that. So I guess we'll just give it like an angle. What angle can we go last? So we want like a... So they did like 3 in there for some reason. Right, so we want like 2 colors, where we want like start color, end color, and then we probably want like a... So it's difficult because when you're given a box, so I guess we'll do percentage wise. Yeah, so we'll say like ratio, start to end ratio, and so that defines how much, how far you're going, and then we'll do like an angle. So if your ratio is obviously like 0, it goes way down here. You basically have full orange, and as you increase, you'll get more and more pink in this case. Then we want to have this sort of radial one. So you have 2 colors again, and I guess you would just have like a distance. Oh no, you just do a ratio again. Sorry, no distance. So it's 2 colors, no angle, just a distance or a ratio. And voila, there's our super lovely API. Go into the UI system and find the... There we go. So we're just going to be uploading the words to the GPU. So I just want to do something like this basically. Gradient. Oh my days, I didn't update these guys, did I? Linear radius. Radial. So we push one word to say what type it is. Then we want to push a word. I'll push it on all of these guys, right? So start color, end color, F32, F32 we're pushing on, start to end ratio, and then angle. So we could convert this angle to a vector, but yeah, let's upload that way. Cool. So the rest are going to be just like this. So we're going to produce that. So inner color, outer color, inner distance, outer distance. Now, got to change these. Hey there, Dr. Merrick, how you doing? So I didn't reply to your earlier message. Hey, how's it going? Yeah, Vulkan is like super duper complicated. Part of the reason why we're doing compute only in this project, you know. Just to see if there's a way to do it with only using compute shaders, and can you make a full game without using all that super crazy, the full super crazy API, and use just part of the super crazy API. You know, Vulkan. So if we go to the shaders now, we want to obviously add all these super lovely case statements, and then we can no. Oh yeah. Great, my render now loads multiple meshes along with the same GLTF model. My next task is transforms plus skeletal animations. Oh yeah. Awesome. Good progress. Good progress. Yeah, the skeletal animation stuff is good. It's pretty cool stuff. And then like the procedural animation as well, where you can sort of like get it to sort of like collide with an object and stop, which is quite impressive stuff. When people have that, I'm like, it's quite impressive because it takes a good amount of work to get that done. So I'm going to read some words in. So the linear, so we'll just do the linear one obviously, and then we'll advance. So we've got start color, end color. Just get all these in. And we'll fit in all the bits and bobs, the bells and whistles. Start color, end color. I got to advance by one word every time. Then we want the start to end ratio. Then we want the angle. I didn't change the function to the F32 one, otherwise it will cast it and not do a reinterpret cast and be absolutely horrible. Cool, so now we've got all of our thingies. How does one do a linear gradient? So imagine our game. So we've got the bounding box, right? So the gradient is literally just going to be plastered over this bounding box, and only obviously render if it's inside the distance shape. So we can take, for instance, like this one here and just do all the different gradients. I think that'll be fun. Oh. How did you not notice there's that music playing? And I talk like every 2 seconds. Cool. So what do we need to achieve said thing? So obviously lerp is involved, right? Because you've got 2 colors, right? So I guess let's not worry about the angle for now. We'll do that in a second. So let's just assume upwards. So essentially, if you're assuming up, so you get the box. You got a coordinate, right? So you can get an offset from the bottom left. So you got the bottom left coordinate. We got a coordinate pixel. We can do like get a distance from there. And then we can say, right, given like how far is it along the y-axis, right? Dot product. You know, let's just do the angle as well. But let's hard code an axis for now to be up, and then we'll do the conversion properly. So we're just going to say, hey, it's f32 times 2, 0.f, 1.f, and then we'll say, okay. We've got this thing called a diff. We love ourselves a good diff. Poor baby's being changed. He doesn't like being changed, apparently. Poor baby. Where's the... Oh, this one. Right, so we get the sort of offset in screen space in pixels. So we're just going to be... So the offset from the bottom left in screen space. Now, you want to be kind of like saying... So you say how Yeah, so we want to say like, what's the exact formula that you want to do? So you say, given this axis going up, apply that to the width and height, right? And then can you dot product it? Because it would be, so you maybe dot it with the axis. See, I don't know which one is. How's the bebe formed? Yeah, he's doing good. He's growing pretty quick. You know, he's starting to be more awake now, which means more, more sort of like crying and things. But yeah, he's getting used to reality. Is drinking so much milk now. Lots of nappy changes. Yeah, it's pretty cool. He's still not smiled yet properly. He smiles, but he's just not, like, he's not got to the point where he can giggle. And so he's just mainly like just flat, like just, or crying. So most of the time he just stays quite just flat emotions. But yeah, soon. Yeah, he's proper funny though. He does make me die. He's great. But yeah, sooner or later he'll be like crawling around, and I gotta remove all the objects from every table. Just I don't know how we're gonna manage. But yeah. Oh. So we've got the offset, and we've got this axis. You could say, I think you want to dot it against the axis that you're looking at. And then you also want to say, and then say, see, you could dot, you might have to dot both the shape of the, like the bounds of the box. And then just do a division probably, I think. And then that'll be your lerp. Something like that. Let's write it right out. See if we land on it. So I think the idea is you want to say like, you want to get other brand new user, welcome. Kill my graphics was dead. Okay, no worries. Yeah, protect the computer. Don't worry, I got the big desk. It won't be upstairs. Alright, so what we're going to be doing is you dot it against. So you got so if you're just going across the y-axis, you kind of just want to make sure that the division only happens across the axis that you want. So I think you will have to make like what's known as probably like the probably just call it the edge, or the sort of like axis extent, or extent. I'm just call it the extent. That's the bigger one. So dot f30 times 2 to be a dot product of whatever that offset is. Oh no, sorry. The yes, it would be this the dimensions of the bounding box with the axis. So it gives you the extent. And then you kind of have to dot the, and then say how much does this offset. Wait a minute. Sorry. Maybe we can just do it with floats. Because you've got your axis. Yep. You can just do it with floats. Excellent. So this is like probably the extent, and then the offset along axis, extent along axis. Perfect. And then you want to say something like offset along axis. Perfect. So if you take a look at that, so you have like the axis is going up, and what you're saying is how much does this offset project across there, and it will give you a scalar value back, right? Because this is normalized, you know, just it's got a length of 1 within the dimensions, which is the whole thing, right? The whole box. And this is just the offset into the box. So then that gives you, then you just divide and get saying sort of like, what is the ratio? Wait, do you need a ratio? Because you could probably just lerp it from there, I think. Yeah, it's the shaded toy guy. But he also did all the sign distance field blogs as well. Yeah, they're not true sign distances when you do all of that, yeah. Yep. They're not, yeah, I forgot the word now. Yeah. What's my Neovan theme? It's based on Ascent, but it's a bit of a custom one where I've changed the colors and stuff. Well, I've just made it more complete. Basically, colored in everything I liked to be colored in. So, get ready to take a screenshot. You ready? There's my theme. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Bam. Yeah, that's my theme. So if we've got these two, this would be in pixels still. So if you divide it, so you could divide offset by the extent across the axis, and then what you'll get is a value from 0 to 1. Yeah, you get a value from 0 to 1. We've also got this sort of like start to end ratio as well. You need, so if you do like a lerp, right? Ideally we want to have like we want to lerp between two colors, right? So these colors here, ideally we should convert those into these lovelies. So I need to do a little unpack. Right, so you want to do some sort of like unpack and get like a full-on color. So at the end of the day, what we want to be able to do is say start color, end color, and we want to smoothly go from there to there, and we want to make get T. So how far? So if you have your offset across the axis, and you got this, it's got to be from 0 to 1. But then you've also got like this start to end ratio as well, so it's like 0.5. It means that directly in the middle, you know, they meet directly in the middle, halfway is directly in the middle. Whereas if you go further up, the halfway is a little bit, it favors the other one, right? So that is, so I guess it's just an offset, right? So the way you can calculate t then is t is equal to offset along axis divided by extent. So along axis. So that gets you 0 to 1. So that would mean it's directly in the middle. So really then all we'd have to do is say add, right, start to end ratio minus 0.5, because 0.5 is the baseline. So this is where we should really make sure that when we ask for a ratio when it comes in, what we're really saying is core debugger set, can you make sure that this here is basically, 0, 0, well, we just clamp it. Core clamp 0, 1. That would be nice, because an assert is a bit, what happens if you have some code that sort of like changes this? It's very error prone if it just triggers an assert, right? No worries, no worries. Did I create a theme command? No. I took someone else's theme and then I just basically added the extra bits to it. And I probably changed some of them as well, because I use tree sitter, and I don't know what the other thing is. Yeah, I think that comes from tree sitter, these things. But yeah, I think so at least. So that would then give us our color. So we can then say source color equal that, and ta-da! So that should be a gradient. So what we're going to do is we're going to copy this one right about here, and we're just going to put it there and do a nice gradient. So this one here. So we want to take the, we need to go up by 1 and to the right twice. So up by 1 is 240. And then right is 300. Cool. We're going to drop the, we're going to replace the border color with gradient linear. So we'll do the 2 colors still. But we want to have this one here. So we'll do a sort of a round radius as well. Chuck that in there. Now this has got to be 0 to 1. So we divide it by 50, which is the max. That'll give it 0 to 1. Oh, I did, didn't I? Because I think did I make like a paste? Didn't I make like a paste bin or something? That completely got wiped from my brain. Yeah, I made a gist. I remember that because. Right, now we all know. Thank you. I didn't even remember that one. Yeah, because yeah, I had a vague memory. I remember putting it somewhere online, but I thought it was a paste bin, so I didn't think it was a gist. Amazing. Right, that's made it far easier to communicate my theme now, hasn't it? And that's made someone type it out. My plan all along. 4 floats, please. Yes. Lerps. Radio. Oh my days, would you look at that? It works. Whoa. So, all we got to do now is get the angle thing to work. And we'll, I guess, do that as well. The lerp is what we want, isn't it? So if it did nothing, let's make sure we do nothing. Sweet. Right, so I don't know if that works exactly. So, good thing that we tried this. I don't think that take 0.5 is good. Oh no, 0 is what we want. Sorry. That's being a dumb. 0.5 is perfect, right? Yes. It defines where the cutoff is. Oh yeah, so 0.5 means the cutoff is in the middle. When you say 0, it means it just goes... Right. Fantastic. So is it the right way round though? So when you say 0, you're getting a whole load of end color, right? So when you say 0, you're getting a whole load of end color, which should be... So we're saying go up. So your offset is from the bottom. Where's the question actually? No, red is the color of healing. You know, it's that blue light that people will scared about. But yeah, it could really go this red color, to be honest. It's not really needed. It was only there to test the boxes. Now that can make someone go blind. I get the joke now. Yeah, not so red. Let's make it not so red. Let's do it. I just remembered it will make you happy. Let's do that. There we go. Doesn't it look way better? Right, so if the start... You know, this also helps us define where the box is as well, but oh well. It'll be fine. Yeah, we know it's all fine. So T... So we didn't have this here. You get perfect in the middle, right? And if we make this explicitly in here 0, you should get... Right, let's make sure that's right. So start color... Really? Right, so something to do with... Make sure it's right. The start color gets uploaded. Oh yeah, green is the... is the color at the top. Yeah, that makes sense. Right, that's perfect. That's good. So all we've got to sort out now then is the axis thing itself. So from what I remember, sine, angle, right, because sine starts at 0. 0 means 0, whereas cosine 0 means 1, right? It's just like when you throw in 0, it gives you 1. And that means it starts to the right hand side, right? Okay. So and that's correct, isn't it? So let's try this out. Now to do this one, we're probably going to pass in round radius, but then we'll pass in, I don't know, is there another number that we're sort of increasing? Yeah, we definitely want to make it so, if I remember correctly, like, so pi, isn't it pi gets you 180 degrees round, right? Pi is 3 point whatever, isn't it? So if you divide it by, so the max number is 50. The maximum of radius can go to is 50, so we kind of want to make it go all the way around and then come all the way back around the other way, basically. So it'll go rotate all the way around, then rotate all the way around back. Well, we could just do pi, right? So, so we know the max number is 50. We essentially want to do like a divide by 50 times by pi, right? So it should just be m pi 3.14. Must be good enough. Well, maybe not. It sort of buggers up a bit. So there's something wrong there. But it does go upside down, right? So the problem is when it flips into negative. The problem is when so we can fix this, we can hard code this in the shader and figure it out ourselves. So the problem is simply this, right? Where we say 0 point and then -1, right? That doesn't really work. It just keeps it the same way, basically. So I was thinking this number should be negative then, if they're different. Right, this one should be negative. Maybe. How do we know? Well, we can know by saying if extent along axis is less than 0, set the source color to like 1 to make it white. Okay, it's white, so it is negative, and then let's just double check to make sure we make it positive again. Then it goes to the actual color, right? So this will mean that what you're getting then is a negative number here, but then a positive number before, then a negative number here. So I'm not quite sure on my math. So if we have, say, like 3 divided by 5, which is negative. I have to make sure I do that right in the calculator. You get negative 6. Right, then I've done plus whatever, right, so then I've done plus 0.5, take 0.5. So if you do negative in a lerp, what does that do? Wait, is this gonna happen, right? Yeah, because if you do that, it doesn't put green at the bottom. No, green stays at the top. So maybe we need an if statement. Say if t it'd probably be it's kind of how does it? Then negate t. Right, so we kind of want to know, like, we're going to say if this one is negative. You know what? T plus equals that. Then you want to like flip t the other way around. Make that explicitly on another line. Then apply it. Right, let's make that -1. So green should be at the bottom now of the gradient. No. What? Maybe it's just to do with t itself, so that the order can stay the same. What? No, what we have to do is invert it. We just have to say 1. Yeah, you know, it's actually really easy. You keep. So that's -6. You say. If it's negative, do you just absolute it? Maybe. Like maybe it's as simple as ABS. No, it's not. Oh. Yes, if you're going down, if one of these is negative basically, and you can tell based on the dot products you get result from this dot products that you get back, or goes the other way. Right, let's see if it lands inside this if statement. We'll do that times 2s one thing again. To see if that worked. Right, so it didn't go in there then. Okay, that's interesting. That should have got me -6 though, right? We did the test. Huh. Is offset negative as well then? So is offset negative? That's the next question. So offset is also negative then? All right. Okay. So if its extent is negative, then you basically just want to. All right. So let's see if that works. If not, we just. No, that's not good. So the next thing then is to then flip the colors the other way around. Right. Right, so it's not giving you -6 actually, so you don't need to flip that the other way. Right, that's it, I think. Perfect. So if we... So this can be applied the same way onto here still. But it's just flipping the args the other way around is all. Perfect. So what we have to do now is just simply re-enable the axis. Oh, it's in the shader we just left. Re-enable the axis that comes in from the CPU side, and see, it does work there. It's just that it's going up and down. Yeah, I don't know what to do. Yeah, let's like put 0.f in there, because sorry, 0.f is a bad number. It's 0.5, right? It's a ratio, like where it splits, what splits in the middle. Is that right though? So I think maybe the normal, not the normal, the normalized vector. Yeah, there's something about this vector. Maybe we have to normalize it. Norm f30 times 2. I don't know. No, it's already normalized then. Potentially. Right, I'm just gonna switch the light on. It's getting a bit dark. Hmm. So the extent along axis is negative. So there's a point at which should we print out the value in the terminal that we get? Let's see how this number actually looks. Angle, because the answer could just be in the number that we're passing in, but I think that's fine. Yeah, so it goes from 0 to pi then back, right? That's what we thought. So that's fine. So let's do sine and cosine of it. So we just want to do like a sine f and then cosine f32. Rightio. Yeah, so right. Yeah, I think they're looking fine. But you know, I think it starts off at negative or something. You know, it goes into negative. No, it's fine. Negative going down. Yeah, that's fine. Do you like thinking about angles in radians or degrees? Well, I think of them in degrees because it's easier. But then, yeah, obviously, radians is what you work with. I haven't quite mastered radians yet. Looking at them. But yeah, this is a normalized vector though. Or is it? Maybe it needs to be normalized. So anyway, we do normalize it now. So then like 1 on the x. And then that's when it goes negative going down. And that is when it goes up. So you're saying like, does this point, is that a good idea? Or do we want to test offset maybe? Yeah, no, that's the wrong one to test. The right one to test is offset. Because offset is the offset from the bounding box, right, of the bottom left. How much does that map to the direction that we're taking the thing? Is that right? Um, no, maybe that's not. Maybe it's the wrong thing, right? To check if this is negative, because if these vectors are pointing different ways, you know, maybe the gradient's going that way, that'll give you a -1 or whatever, a negative something. So is that the right thing, eh? Yeah, I'm starting to think radians due to my physics class. Nice, you got it. Yeah, degrees is just what I grew up with, so just what I know. But I'm sure if I spend a lot more time in radians then I'll probably understand it more. So an offset from the bottom left is, you know, it's an offset, it's a pixel coordinate, but we're treating it like a vector. So when you do a dot product against it, or even the extent is like that, right? It's just a, you know, vector that spans, you know, it's from bottom left to top right. Yeah, so that's where it buggers up, is here, isn't it? When it goes in that opposite angle. When the angle goes diagonal, it gets a bit different, doesn't it? So I'm thinking the fact where we decide to flip these is where the problem is. So based on this. So that would then mean you probably want to say, so you have the axis, right? So the axis is going to say, you know, so if it's going that way, it's going to be 1 on the y. But if it's going that way, it's going to be negative on the y, so you want to flip the colors the other way around. If you're going that way, it's going to be positive on the x, right? But if you just go a little bit over, negative on the y, right? So you want to flip. Do you want to flip the colors the other way around just there? Weird. And also, do you flip them? Wait a minute. So if you have, right, so if your angle's going that way, How do we decide when to flip it if any of them is negative? I guess let's just try that and see how different it looks. I'm not sure though. I don't think that's the right answer. Right, so that one, when it rotates to the right, it does... It flips. So when it gets to like... Yeah, whew. So if any of them are negative, then flip the colors the other way around. Yeah, so that's not right still. So maybe the answer is, hey, if the sign of these are different, right? So you say like if this one, so let's do something like this, right? If the sign of these two are different, let's see if that is something. Oh. No. It just looks really weird. It's smooth though, unlike the other two. And I guess we could print out... so we could get the offset and... well, maybe print's not worth it. Yeah, no, because if this ends up being true at any point, which it does because they do probably flip, right? So should we try? Then I think the t value ends up being weird at some point. Let's try and run that one. Right, so it does become white. Only for those ones at the bottom. Okay. So because we know that happens then, it means this value at some point, like, is negative. I guess we already knew that, right? If t less than 0. Nope. No. Oh, it's the same sort of thing, right? Yeah, same sort of if statement. So that's problematic. So it's only for certain pixels though where it actually reaches that. Okay. So when we had this thing here, where was the other one that we had? Based on the offset, wasn't it, or something, right? That one keeps going okay, but then I guess the t values mess it up. It's hard to see. So we stick it at about, you know, a hard code. Let's get rid of this angle thing. let's stick it like a hard-coded 2.5 radians. So that's not all the way around. That's 100 and, I don't know, 60, 100 and whatever. So you get this sort of like weird line here. Maybe that's a bit too precise. That's dead on the issue, isn't it? Right. So this one, kind of good. These are where they go negative though. Where this goes negative, one of them goes negative and brings T down to being negative. I'm not sure if I'm using the wrong way of working it out. Because you've got the sort of the axis. Right, let's just draw it a bit. So we've got this box. Which problem are we trying to draw? So 314 divided by 2 is about 1.6, right? So 2 is somewhere in between, so it's about 45. You know, it's like, it's kind of pointing down like that direction. So we've got like, so if our pixel so the pixels up here, they do the dot against this, and obviously it's negative, right? Whereas the ones, the vector that goes up there for the size does the dot, and it's like, you know, the dot against that. And it might be positive still in a way, right? It just depends. So you end up getting this with a different signs. So do you always want the absolute for this one? And then based on whether it went in the negative, then you flip them the other way around or something. So maybe you say F ABS. Something like that one. Let's see how that looks. Right, so that's kind of like, it's brought the gradient back, but it's like, it's wrong. So ABS is kind of wrong. I guess if it goes the other way, you want to maybe do like a one take and invert, like mirror it instead of well that's what the ABS does, right? Just mirror it back the other way. Ah, damn it. Maths. You know what, let's take a little bit of a break on this one and let's go and implement the next one, and we'll come back. A little bit stuck on this one. Because we've tried absolute in those. So it does happen. Let's just try one more thing. Let's just try one more thing. So if t is less than, right, that's kind of brought the same sort of thing, I think. So then if your t is negative, so your extent against this vector, you're saying that the gradient goes that direction. Meanwhile, your point is up here, so it kind of has a vector like that. Right. See, I think the problem is you can solve this. Like you're solving it for 4 different like what you're trying to solve is like, you know, how far is this across here? So hey there, I'm programmer bro. What's the current route for graphics programming? Do you reckon going through OpenGL, figure out the rest? See, I'm not really sure the best sort of way to go to graphics programming, to be fair. It's all quite crazy because all the new stuff is for literal experts, and it just takes ages to learn it all. But in all honesty, it's probably best trying to go to the basics and write a software renderer. It'll be dead slow, but you basically want to write like a triangle rasterizer, right? And just build your own 3D renderer yourself on the CPU and learn exactly how OpenGL and Vulkan work under the hood, and then you'll have a full understanding of like what they're actually doing behind the scenes, and then go and pick up a graphics API and learn those things. But you have a much easier time understanding things when you sort of know how it works from the underneath, basically. But yeah, there are tons of little courses online you can take to learn how to make those. I think there's this guy called, I've met him in person. I follow him on Twitter, aka_X. Where am I going? I can't remember his names anymore. There he is. No, that was Derek Hugh. Wrong person. This guy sells some courses of, and they're pretty decent. Is he one of the people who I follow? You don't follow a lot of people, you see. Maybe not. I think he follows me though. See, I can't remember the guy's name. It's pretty bad. No, it's a good reference. Honestly, it's a really good reference. That's why I want to find it. Oh well, I'm not gonna find it, I guess. No, ain't gonna work. Oh well. Nah. Oh well. But yeah, honestly, I recommend you write software rasterizer. Learn it that way. It'll be slow, but it'll teach you a lot. Man, it's so warm in here. Yeah, so all we're trying to do is we've got gradient going across this point, right? Okay, going back to first, just going back to the beginning again. You've got this point here, so we sort of take this vector and we say, hey, how does this vector map across here, right? Right, and it's going to give you negative. What is it going to give you? Wait a minute. So it's like sticking. Yes, so it's like how much does this vector map across this one? So you sort of like. So this is a normalized vector as well. We've got to be aware of that. It's a normalized little arrow. So it's as if you're sort of like, so this vector here that defines the gradient. So you're saying how much so we're saying imagine if there's a vector going across this point. So we could make it a vector that spans this whole thing. And then if you have something like, so you kind of want to know like where across this line does this thing end up at? Right. So if you say if you had the axis as some form of like half extent or whatever, and then going in the direction to the edge or whatever. Well, you already have it here. Well, we could multiply it, right? Yeah, we could multiply it by the extent. We're not doing that, we're doing a dot product. So I think this is where the problem is. Yeah, if we multiplied it, we would get an arrow going from, yeah, and then you dot it against that probably, right? Now you got, So you want to say like where on this does it fall? Wait a minute. So the thinking is like, what happens if you did? So this is obviously normalized, and you multiply those two together, you'll get. So you'll get a vector going down to like there, or whatever. Now you've got two vectors, so they're not unit length at all. If you... So you say, how much does this one project across this one? Well, it gives you... See... So I think we have to normalize this one here, and then we can say the dot product of this normalized vector and this one, and then it will give you like this number. Right. We might need to see. I think we might have to normalize one of these vectors and then multiply it again or something. And anyway, so if we get, say if we get this, yeah, but we times it by that, it's not way. Right, so I think this can just be normalized, and if we did that, it will say how much does it project to be like negative whatever. We're doing A/B/B tests. No, we're trying to get a gradient to work. I'm just trying to figure out how do we get, because we've got this axis to spin around. So we basically are defining a we're defining a gradient, like a linear gradient, and I've got like a little axis to sort of like rotate it, but when I rotate it, it doesn't quite go around smoothly. That's the problem. So yeah, we're just trying to figure out that one. So I'm trying to figure out the maths behind it, basically. I had it mostly working. It's just this rotation. Yeah. So we have like a normalized, we have a normalized vector of the axis direction we want the gradient to go in. We have the vector to the current pixel. If we dot the two together, we get how much does this, like given this direction, now how much does it go in that direction? You'll get like a negative, you'll get this vector basically, right? That's the vector you'll get. Or not the vector, the scalar value that points you back across. If you multiply by this one, it'll get you back to, it'll get you this vector here, right? That goes that way. How is this useful? So you've got a scalar that tells you that, right? And that's what we have, oh my days, already. So it's negative. So then, so given that number, transit compiler stuck on the parsing stage, got the tokens, don't know what to do. Hey Zakazaka, you've also got the you know, crafting interpreters book. I don't know, have you been following that one, crafting interpreters? Yeah, it takes you how to make a tree basically. It does all of that there. Yeah, recommend this resource. This guy's made a few quite a few notable compilers. I think he works on Dart. Yeah, the Dart virtual machine. That thing. So we get the scalar value, and if we multiply it against this axis vector, which defines the gradient, it will get us this vector, right? But that vector's not useful, but the number is, right? So it's negative whatever in pixels, right? So it's that projected across there, okay? Right, so I think this is a good way to go. So the next thing we need to know from this point is how much. So we then get the extent, which goes all the way up there, and then we multiply. But we was doing a dot product before, right? But if we multiply it instead, it will get us effectively this going all the way across there, right? Is that right? Yeah, so if we get those two vectors, no. So we did a dot product with this and this. It's going to give me... See, maybe that is right. So you have like this extent that goes all the way up there. Right, and then we have, say, this vector that goes this way across this axis. Well, that's gonna... This is a really oddly shaped box. But anyway, it gives you the right angle, right? It gives you the scalar value that gets you all the way. So if I were to multiply it across here, it gives me this vector here, right? So it gives you the right angle. Yes, how much does that project? Oh my days. Damn it. My brush size is buggered. Right. Way too big. Alright. So it gives you that sort of like... Right, so this is what I've been working with, right? So it gives you that scalar there, that scalar there, okay? So... Right. Okay. I think this is useful information. So basically it's a negative number if it goes before the halfway point. Is that for all cases though? And then it's a positive number if it goes past the halfway point. Let's try that again. This time we'll do it with... Right, so this time I've got one going completely to the right. And we have our point here. You've got this vector going there. So that's our pixel we're trying to render. Then you do a dot product with that arrow and that one. It gets you this. It gets you to here, right? So it gives you a scalar value to say if I multiply across this arrow, you'll get here basically, right there. You'll get a vector going like this, right? So then if you take your extent and then you dot it with this, you'll just get an arrow that goes all the way over here. Interesting. Right, so you can arrow goes all the way over here, which then means, none of them are negative, are they? in that case. It's only when so it's as if maybe what you have to do is keep them all positive, like keep the direction itself, the axis, have like an absolute axis. I don't know, if you have like an absolute axis all the time, then none of those will have a problem. So if you have like it going that way, the dot product between any of those is always going to be fine. You know, never goes against it, does it? Or it goes negative. Right, same with that one. The dot product against any of the pixels like that are all fine. And even going completely right, they're all fine. It's as soon as it goes negative, that's when you've got to try and do dot products between that and that. And what happens is you just get a negative thing, right? So what can we do to make to solve that problem? Well, if one of them is negative, then like, so say if we like did an absolute of both of those, so that's mirrored, but that's just along the y-axis, but then absolute of both of them kind of goes that way, right? And then you did, wait a minute, kind of goes that way, didn't it? Yes, then if you did like a dot product of that, what it gets you is gets you sort of there-ish, doesn't it? Which we could then work with as a number really easily. But then again, yeah, we can work with as a number. So if one of them is negative, you probably want to flip the colors the other way around. But if both of them are negative, you probably just want to make it absolute. I think that's it, right? So you have a sort of like an ABS axis. So ABS F30 times 2 axis, something like that, yeah. So when you're working with axis, like this was fine. But the thing is like, well, if one of those, like this is all fine. The problem is like, well, if one of them is negative, then you flip. So if axis.x or axis.y is negative, then you want to flip the start and end color the other way around. Maybe that's it. We might have to invert the T the other way around as well. I'm not sure actually. Right, that looks good. I'm not sure what it was looking like before, to be honest, but it looks good there. So let's get a bit of animation going. Right, that's definitely looking smoother. It's flipping in a bit weird ways though. So green at the top is the original, and it's meant to go a 180 all the way around. So clearly, I don't know if the flipping is either working. Oh shoot. This is meant to be everywhere. Let's try that one. Does it need to do the flip? That's the question. Now really, I don't know, because thinking about it, right, so the problem is it flipped, so it's doing it, it's going to there and then going back. When ideally we would like it to keep going all the way. But if we flip it, it's flipping, so it's flipping at the right time. But the problem is I think t needs to now be t equal 1 take t, something like that, so it goes the other way around. Just when you think you got it. Maybe we just need to flip t the other way around. Nope. It's close though. It's definitely smooth. So when you reach 90 degrees, you want it to... Oh, no. I don't think it's anything to do with the lerping at this point. Has this done anything? So it just ends up just going back. Axis less than 0. So if any of them are negative. So if your y is negative now and you've gone and reprojected it over, you know, you've gone and absoluted the axis the other way. So you've sort of got your point here and you've got a t. So the t... But it's like your t is here. Your t is obviously, so being that way. You've got to mess around with the t a bit. So your new vector's there, and you do the dot product against the current pixel, gets you the scalar that gets you that far in. So it means you have to change. It's as if you've got to change, like the coordinate. The coordinate itself has to be remapped as well if we do it this way. See, I think there's a very elegant way to do this. I'm just missing out on like but it gets branchy if I'm trying to remap the coordinate as well, but yeah, I see what it's doing. So I guess going this route isn't good because we'll have to then branch to then remap this pixel so as if it was in the right place for this sort of arrow, right? You see, you're like sort of rotating them into the right place. So that's not a good idea. So what about, so this negative value, why can't we work with it? That's the other question. So you've got the pixel here, you've got the vector going, the axis of the gradient going that way. Obviously you dot it against it, it gives you this scalar value here, so if you multiplied it, it'll get you that vector there. So why can't we work with this negative value? Because then if you got the extent and dotted that with this axis, it would get you, you know, somewhere all the way down here or whatever. Right, I'll get you here. Right. So then, whatever. And the negative would be up to about there. Something. Given that. Yeah, this is really sloppy drawing, not gonna lie. It'll give you something like that. Anyway. And the other one will give you something like over here or something. Whereas if they're both negative, is it fine then? Yeah, so I think the problem is if one of them is negative and the other one is not negative. That's probably the issue. So we've got this dot. So if one of them is negative, let's get rid of this axis ABS now. That goes away because that was not good. So if one of them is negative, and the other one is not negative. Yeah, so they're both are equal to the same sign. But if they're not equal to the same sign, you have to process the t differently. So the way you would process, so you would get like a negative, see what value are you getting again? So you're getting how much it will go across this axis. So this would mean if you offset it by this number, yeah, I still use GF when I need it. It's really good. How about you? Are you using it or are you using something else? So I think we add this extent to it along the axis. That would mean, so if we add the extent along the axis, that would then give you, so if you do the division, it gets you a negative number. Yeah, but all it's going to do is give you like a negative 0.5 or whatever, which is fine. So you just don't take the 0.5 at the end, I think. Maybe that's it. Getting close. Getting close, I think. So I think we just don't have to flip these anymore. There's so much flipping going on. What is going on? No, maybe not. Usually live LLDB in the terminal. Yeah, I never really understood that LLDB thing. I tried it out and I was like, this is just like GDB, but different. And I was already used to GDB by then. Printf debugging, nice. How is LLDB compared to GDB? So there's this offset. and you do the division, and that should give you a signed signed norm. So because you've got signed norm, maybe you just say times 0.5 plus 0.5. And then you can say so then that'll give you 0 to 1. Yeah, I think that might work. Weirdly flips. Tell you that. Weirdly flips. But we can hardcode the axis. See if we can catch it. See, that's fine. No, it isn't. That's when it's flipped. Let's go to 2. Right, that's not good either. Because 2's like diagonal going down. So imagine it's all the pixels are going in here, right? They must all be going in here. Yeah, so all the pixels are going into that one. So we just got to solve this properly. So we got to make that look good. So if we just did this, it should still look the same. So the diagonal is not quite in the middle. There is it. So why is that? So if I was to do this, what would happen? That's in the middle now, right? Fantastic. So why? So if we were to then add, this can't be right. Same problem. Okay, so we keep going then. So what have I changed then? Nothing. So if I keep going and go to 5, try and get it all the way around to 180. That's when it looks a bit dodgy. It's sort of has decided like yeah, it's all in Vulkan. Yes, using compute shaders. Yeah, I also have a little custom C compiler for shaders so we can share code between the CPU and GPU. Right, so definitely in this branch. So why then is T wrong? Like, we expect to see green at the right-hand side. So what we can do, So should we just display well, the stream is titled Game Without an Engine, so yeah, we're running a game. 0, 0, 1. Okay, so we're clearly seeing that at the halfway point, it goes into the negatives, and then, you know, right at the halfway point, it goes into the negatives at that point. So if we change this input to this one, is that still the same case? Well, it's over there instead, is where it goes into the negatives, right? So it's not always fair, so this division, you shouldn't divide that by that, maybe. It's bugger. So the angle was a little bit more, it wasn't diagonal, it wasn't directly to the right, it wasn't directly up, it was sort of in between. And the offset became wrong. Will the halfway point become offset? Why is that? Offset along the axis. So the axis is going across here. Just about falls into the negative, right? So it did it like a 1.5 or something, right? That would be like half of pi, kinda. That gets you sort of halfway. It's fine. Shoot, let's get that back to 2. So that one isn't good. So why is offset axis? So it's negative at that point, and then it goes positive. Let's draw it out. Axis going that way. Pixel, vector, right? The dot product gets you somewhere about here-ish, right? Negative. Whereas if the pixel's like here, from here on out, it goes a bit. See, this box isn't good box. Should start with better box. Right. So it's going that way. Your pixel's up about here. Right, it's negative enough. It's just about negative here, just about. So obviously this whole area is black, right? At that point. Debug arrows would help. Yeah, I guess. Don't have a good way of drawing those. But yeah, they're definitely a good idea to get into the game at some point. So like what are we trying to achieve from here? Well, we're trying to make it so that really it's directly down the middle, isn't it? That this kind of line here, where it's a right angle, is kind of like directly down the middle. So Yeah, I think I'm just calculating this way wrong. Like, all you're trying to solve for is like, we have this line going across here. Where is that on the line? Right? Where is that on the... So like, you've got a line going from... Like, it's a way... We're trying to... It's too complicated the way we're doing it, right? We're trying to do from down here, and it's just proven not right. So this is the line we're trying to get it across. You got a pixel here. Where is that across the line? So say if you, and we're doing it from origin bottom left. This is part of the problem, right? Why don't we just do it from origin 0 in the middle? Or does it make origin 0 in the middle? Then instead, when you have your thing that goes across, right? You got to make sure that this line goes across the middle, right? Okay, that's better, right? That's the fix, I think. I think that's it. So we should really think when we have offset, it should be offset from the middle of the. So what you should really do is say add f32 times 2 mol s f32 times 2 command ABB dimensions divided by 0.5, right? So that's the difference from there now. So obviously it's going to probably be negative in that, but we can offset it. So now instead what we've got is an offset from the center, right? Now with this axis, right, it's just a normalized vector. So if you have a normalized vector, so you got this point. So you got like this pixel over here from the center position, you got a vector going there. You've then also got your direction going that way. So you're saying how much does the projectile there? So you dot that against the offset against there. Right, that's all you care about, isn't it? And that's your t value, right? Scaled in what space though? Pixels? I guess you could do the extent across it, right? And if you do that, maybe you keep what we've already got. But now you know one of them is always going to be. Now you know that yeah, you're not going to have two different. Whereas from when it's down here, I think that's yeah. Yeah, when it was down here, you only sometimes had negative values if the axis was in the negative area. Whereas if it was in the positive area, you wouldn't have had any negative values or something like this. So by doing it from the middle, I think it's fixed that problem. So the question is, how do you get t now? So see, axis is normalized. I don't think that helps us. So maybe you do it across extent and do what we have been doing. Do the division. But now your division is from -1 to 1, and we know that. So all we should have to do is multiply by 0.5. So that halves it, so it gives you 0.5, or -0.5 to +0.5. Then you want to add 0.5. Then you just add your ratio. And I think that's probably it, although we might need to reflect it again. Let's have a look at that. So it's off, obviously. What's the problem? What about this? What's going on here? Right, so let's put it down the middle. My calculations are a little bit wrong though. Why did I think... Why did I think not to... Right, this already adds 0.5. So if we add 0.5, it makes it 1. That's also wrong interpolation. You're missing something with gamma and linear color spacing. Ooh. What do you mean by that? Do you mean the value we're passing in as the t value that we're calculating, or do you mean the lerp in general? But yeah, I see what he's... Right. Maybe. Right. It's the lerp, is it? Because if we were to say, should we see if we've fixed it though? Let's put this back. Yeah, it is getting really ugly, isn't it? Oof. No, it's wrong. Still. So I think we still got to deal with the fact that you got to... That's the same problem again. I think we've still got to deal with the... so the extent via this, and you probably get a... See, it's the extent again, isn't it? Is that okay? Yeah, the extent across there, so it should get you something like that. Yeah, you can post an image, that's for sure. Post an image. Please do. Extent along an axis. So the extent is going up there, and then we've dotted it, so it gets you sort of like the scalar value, which could make this vector. Yeah, that's what you want, isn't it? So if that is always going to be like 1 or something, right? So for instance, you'll get like, if it's going across that way, you'll get like 1. And this give you like a negative whatever. 1 along the x-axis, just give you a negative whatever across the neck of the x-axis. So you're saying then negative whatever divided by 1. Well, sorry, you get the width on the x-axis, sorry. Yeah. So that'll give you some value between negative 1 and 1, it must do. Yeah, we need it very much. Yeah, his images that he mocks up, they're good. See, I've not done, I think I've done gradients before. Maybe it's just a radial one. You know, but see, the radial one and the distance one is a lot easier. Like, it's just mapping, doing this, well, it's easier for me at least. Like, they're just, where it should be. Oh ho ho, got an image, thank you, sir. Right, classic interpolation. Oh. Uses cubic interpolation. Usage the gradient option will work on designs that include gradients created in older versions of Photoshop. Okay. Interpolates the gradient in the OK Lab color space. In the linear color space. Ooh. Yeah, that looks it, doesn't it? Yeah. Yeah, that's not good. Right, I'll keep that in mind, thank you. So we'll keep that open. Just got to get the t value right, but I think it's correct. You're doing that divided by that. You know, you should in theory just have to do this. But then you should, because it's just a couple of plus and minuses, you should just be able to get rid of it. Wait, because that'll get you... That'll get you 0 to 1. So this gets you 0 to 1. Should do at least. This one is like a start ratio. 0.5 will be in the middle. So it's kind of like just an offset, isn't it? Yeah, so you are, yeah, so that is right. You just, it cancels each other out. Perfect. So right. So I guess we can color it via the offset again. And we get to see that, right? So we can just do something like this. If they do some, we'll get an offset in the offset along the axis 0, 0, 1. So with that you should, right, so that's kind of where you want it, right? Dead down the middle, right? That's where we wanted it. So let's rotate it around. You know, let's just get the rotating code going. And does that, that is perfect, isn't it? That is what we want. Like, so it's simply how we're now deciding what is fully on and fully off. Sorry, how we're normalizing that down to 0 to how we're normalizing it from 0 to 1. That's the problem. So offset axis is fine. It's just what we're doing to get t now is the issue. So maybe it shouldn't be the dot product. Maybe it should just be a no. Multiplier will give you a vector. Dot product produces you a scalar. So if it produces you a scalar, so let's see what it looks like if we do this. It looks dodgy. So it's probably because one of them is negative, then the other one is positive or something. Well, it's that sort of same problem again, isn't it? So let's ABS those. Oh my days, this is taking so long to do this one. I thought I'd be doing a lot more today. Right. So obviously ABS is not right. Yeah, because we want to be negative, right? Yeah, one of them negative, one positive. Yeah, we knew that. Sorry, we already knew that, right? But as soon as it gets to that diagonal bit, it's right. It flips. Right, it's the... So... You got... This is the extent vector. Maybe that is wrong. What we're trying to say is, given this vector, actually, where is the point along the edge of this box? That's all we're trying to work out, actually thinking about it. Given the axis vector of the gradient, where is the point on the box? Is that right? Yeah, how far does it travel till it hits the box edge? That's it. This is why I never write from absolute scratch. Yeah, I always do it because I want to like, it's the best way to learn. You end up like scratching your head against the wall sometimes, but it really helps you like really concrete, like um like my ability to use like dot products and things like this is, you know, it's okay. I definitely had to sort of re-remember it for a second while I was doing this. But it's allowed me to like, you know, sort of solidify it all, you know. But yeah. Yeah, always do from scratch. Because you get much better every time. So do you want the point where you want the sort of like the distance maybe is the dot product, right? Well, it's kind of from this point. How far do I go until I hit this thing here? Given a scalar across this direction, that's what we want. Don't you just want to rotate everything now? No, that was one of the ways we could have solved it, is rotating it. Oh, you mean rotate the... Given the extent, half it, rotate it. Something like that. Hey Frank, yeah, it's not going bad, not going bad. Does it simplify the maths? What are we rotating though? You mean rotate the... You can backseat if you want. Code. If you have the answer, I would appreciate. Oh, you got in a shader toy. Just an idea. Or how's this way do it? Yeah, but we want it to go all the way to the edge though. Interesting. That's the point. Maybe ours needs to be like this. Where you define a start and end point, actually. Yeah. Yeah, mix is just lerp. It's just lerp, is all. That's all mix is. It's just GLSL being silly. But yeah, I think I need 2 points then. So it basically gets the position in unsigned norm space. Wait. What? So then it takes... and divide by 2. Right, so then that converts it to -1 or 1. Yes, this converts it to -1 to 1. So this is U-norm, signed norm. And it gets you points in signed norm space. And then it does the dot product between between the UV and the between the UV and the mouse normalized. So if the pixel is here, pixel point divided by length. Huh. Should we draw this and figure this one out? Yeah, let's pretend and just copy paste it. Maybe. It's definitely a lot more elegant. Right, I want to understand it. I want to understand. So you've got like... So where the mouse is, that is the it's not the axis. Oh yeah, it is, because it's normalized here. There it is. Yes, that is the axis. So you've got your like box, very wide box for some reason. You've got like... So we clicked here and end up getting like an axis going that way, right? So we've got an axis going that way. You're trying to render this pixel here. You're getting the dot product between this vector going to that point. Maybe that's a really bad one. Let's do this one here. The dot product between these two, so it gets you somewhere like a little bit in the negative space, right? That sort of distance off there. So that's what we had before. But then apparently you should take the length of this to there and then divide it by the dot of that, right? Which I would have never figured out. That's the bit I didn't figure out when we was doing it the other way. Everything is from the middle? You sure? How's it from the middle though? Frag chord. Let's get the question mark. Yeah, this is shader toy stuff I don't understand, I guess. Oh, it says from the middle in the documentation, doesn't it? Right, because it's going... Yeah, it says make it signed normal instead. Yeah, let's make it signed normal. Right, that's what I... Okay, so it is from the middle like we was doing then. Okay, so imagine it's the point over there. You're doing the dot products between that and that, so that'll get you something like, you know, this thing here. So that's what we ended up moving towards, right? So the bit I didn't understand then, the bit that I didn't kind of get is like, well, you've got... so you got this sort of like the length of this divided by that. That gets you D. D plus 1 divided by 2. Because the distance between here to here is 2. So oh. Wait. Then you're adding 1. So from column to color 2. Fair play, I never figured that one out. Or made it that elegant at least. It would have just been like incredibly poor. As you can tell, maths isn't my strong suit. So what sort of numbers do we need now? Color 1, color 2. We've got the axis. But not the axis anymore. Well... See, this one it isn't shifted as well, but we could always shift it. Yeah, it isn't. That's fine, thank you. Appreciate it. So the thing is, like, we could offset this gradient. Like, that's what... Like, the way we're looking at it is like, well, it's kind of smooth across the whole thing. Like, what do we want? Do we want this? I think we'll just do a smooth gradient for now. And if we want anything else, we can always just do it. So let's just like shift it. So all we need is the axis then to the edge of the... Is it? And I've already got it normalized as well, isn't it? Right. Right, so we've got this, and we want to convert it from like, so coordinate, take away divided by the dimensions. Something like that. So that gets you your sort of like, right. And then you want to multiply it. So that gets you your offset in 0 to 1. So that's offset u norm, offset sine norm. So that will be like times by 2 take 1. Offset u norm. Take 1. Hey Sockham. How's the progress? Pretty pants, to be honest. We just spent like the whole stream so far trying to get this one gradient to work, but the rest should be easy enough. I might be able to just do them pretty quick, fingers crossed. So that gets you your sine norm. I guess we can take this and plug it into here just quickly and say dot x dot y just to check that actually is what we think it is. These two need to be all commented out. Right, so we are getting red down here. What is going on? Take away the bottom left. That gets you the offset. Then divide it by the dimensions. Why is it flipped the other way? Like it's flipped along the... Oh no, it's right, isn't it? Black bottom left, red to the right, green Y, perfect. Right, so there's your norm. So sine norm, great. So we've got this value here now. Well, this one here, P. So the next one we need is this one, which is just axis. Also, by the way, how the hell is a CPP compiler so slow? My goodness. Yeah, it is slower than a C one, that's for sure. It's because they do lots of extra stuff. So we just need to do a dot product. So we just need to get a D apparently. That's all I was missing is the D. So P meaning the thing we just made. Offset snorm. Good old snorm. Then we want the axis in there, apparently. So that gets us D. So we put D, plug in D along the x-axis, along the red channel, see what we get. Yeah, I think I've already done that. Oh shoot. Yeah, because minus 0.5 gets like divided by 2. That's just converting from 0.1 to -1 to 1, isn't it? And I think that's the same, isn't it? Right? So you do like, oh my days, get rid of all that. You know, so like 1 take away 0.5 divided by 2. Wait a minute. Is that right? Wait, why did... I think I punched into the calculator wrong. Must have done, right? Yeah, then... No, that thing's doing it differently then, it must be. Because if UV is... Like, that's the same as converting it to... Like... Yeah, that value is a little bit weird, isn't it? Yeah, this one is... Yeah. See, what happens if we do change it to times 2? Didn't really change anything. Frankly Gamer, I just graduated as a software developer. I'm now gonna do a challenge 100-day coding plus commit to no gaming. Very nice. Yeah, pretty much just 365 days a year coding, basically. But yeah, you got this. Yeah, basically, like for me, the oh, this is your shader, even better. I've always someone else's shader grad. Nice. Yeah, yeah, exactly. So I don't know why the divide by 2. Huh? I'm really confused. Like this P, like if we plug that, yeah, it must be. Like we plug that into. It's working apparently. Ah, yeah, different. They're different values, but it works the same apparently. The reason why it works the same, it's definitely a typo, but the reason why it works is because this gets normalized and that is divided by the length. That's the reason why it works. Right. I'm glad we came to the conclusion of how it works. Good. Thank you. So after the dot you get D, and then all we have to do is do a good old lerp. So right, we made it more correct, but it didn't even matter apparently. It did. Your code was so robust, even a typo didn't matter. Now that is some good code. D plus 1 divided. Now is it a divide? That's the thing. No one knows. Right. Here we go. It works. Would you look at that? So, is this gradient thing fine in the middle? Yeah, 100% wrong. So how do we fix that? So if you make like, wait, what sort of colors are we doing? Yeah, you get that sort of like murky color in the middle, isn't it? Looks horrible, doesn't it? Yeah, so that's the thing we've got to fix somehow. But anyway, I'm glad we got the angle. It took like hours to get the angle sorted out. That's what you call productive. It's because everything is linear. You need to gamma correct. Right, it's in linear color space. So basically it needs to be... Right. So... Right, you convert it to like sRGB basically. So, you know, if we've got like a PAL... Do I have PAL? Let's just see if we can change it. What are we doing? Wait a minute. I'm not writing my colors out properly, am I? Yeah. So, right. So the colors are linear. That's it. But when I write out to the texture, I'm just writing it. But then if you look at the color output, right. I think this could be it. What's our format? Wait a minute. GPU. Right, but the surface format... Yes, we say it's sRGB, but we have to basically encode the pixels ourselves into sRGB format. Yeah. So by default, Vulkan, you know, if you're using a pixel shader, Vulkan's going to be like, you know, it has like a VK format, 888, you know, there's a UNorm version, but there's also an sRGB version, right? So all sRGB means is when you sample or when you store it back. Oh, wait. All sRGB means is when you sample or when you have a render target and you write to it via render target, it will do the sRGB conversion for you. That's all it means. So when you read it, it turns it into linear. When you write it, it turns it into sRGB from linear. But the problem is you can't use sRGB when you have it as a storage texture, right? It's only when you start, kinda. Yeah, that's it. Yeah. So this is like an estimate. But yeah, we basically need like our own function. So we need to have like we kind of need to have our own like utility section basically. So we'll have like a GFX. Maybe, I don't know, shed.h, something like that, right? So like pragma. Do we do much in the other one? See if the core shared, that'd be good. Right. So we basically just want like a so we want like a GFX S or linear to sRGB. So we'll take in our pixel and then you do like a PAL F32 times 4 color. Then, right, you got to worry about that alpha channel though, isn't it? Yeah, you should only really do it on freeze, isn't it? Dot. Yeah, but then it's not shared. I have swizzling, but it's not. It's only in shaders. So if we want to make this across shaders, then I got to do that. Yeah, so this is just an estimate, isn't it? It's an approximate. Yeah, it's just the very dark shades it doesn't do. Yeah, so I think we'll call this one the fast one. But yeah, have you got the code to the other one? Science code. Thank you. Excellent. Thank you, sir. So you do like PAL times 3, 1 divided by 2.2.f. Right, so this gives you the vector 3. Let's call it v. But then you want to return v dot x, v dot y, v dot z, color dot a. Right, you just need to gamma correct the colors, not the alpha. Good. Right, where's all my types? That's the question. HMath types. Nice one. Yeah, it's fine. Like the compiler will constant fold it, but yeah, it's good. Yeah, we were in a game in C. No biggies. Right, so I want to gamma correct this. So I want to say final color equal, and you do final color. So we should obviously have like a vector 3 version of that one. So maybe we say, hang on, screw it, do that. If I need to change it, I can change it in the future. Right, let's try that out. Right, that looks extremely white in the middle. Everything looks more white. Right, so the problem is this would have been in the texture when we read it. Right, these colors are better. Is that right? Are these better? No, they're not, are they? Something's bugged up. Yeah, because the way I'm thinking about it as well is that we've sampled from a texture, and that texture would have been in sRGB space anyway. So we've got to go the other way around. So that's linear. We also want to go sRGB to linear as well. And maybe we should static inline these so it works. Right. Yeah, because the colors looked way better, wouldn't it? The other colors did at least. So you're saying try red and green on that gradient. That looks good, doesn't it? Yeah, because these looked nicer, I could tell, but then I could tell this was wrong. Because it needs to be the sample. We need to go linear from sRGB. But something's off. No, it isn't. It's smooth. Red all the way at the edge. Yeah, that's good. It's looking better. We can try it. We'll flip it back just so we can see what it looks like again. So yeah, so there's the horrible color. But yeah, these they look off, right? But then when you do the proper sRGB conversion, they really, yeah, they pop and look far better. Yeah, they're correct. Yeah, they're correct as it gets with the approximation. Oh yeah, this is a nice. This is like, yeah, there's a problem in this color when it gets dark enough. So it's like we're just going to do something completely different. Is that right? And then hopefully it's smooth enough. Oh my days. Oh wait, down here. These are the better ones. Yeah, that's funny. Yeah, it's only when it gets super dark, I guess. But yeah, I guess we want like um cut off. Pretty smart, I guess. Yeah, it's just PAL. So then we want like an sRGB to linear. That should work. So we run that when we do our texture sample. So we do our sample. Now, not that one because that's just alpha, and that should be in linear space, right? Not that it matters at the moment. Whereas this one will be sRGB. So you convert that one. Wait, that's the wrong code. This is the commented out code, which should disappear now. Damn it. This is the new one. Right, so now that should fix the color of the texture. There you go. That's good. Oh, we get in there. Oh my days. So if we take this at least, we can get more correct versions. You know, I'll do these later. I want to do other things first. But I think these will just be good to keep here to do more correct versions of sRGB to from linear. Yeah, do it later. Stays in there till the game releases. Yeah, not. Yeah, it'd be good to see the difference. Right, so now the other two are gradient radial and gradient distance. So radial, if you remember from this thing, is going from the middle outwards. So that's probably gonna be quite easy to do. And the distance one is using sign distance fields, and we should just do a distance from the edge. Right, I need to be back in 2 seconds. I just need to take a pit stop, but then we'll carry on. But thank you. I'll be back in a sec. So enjoy the tune. Right, welcome back. Welcome back. Yeah. I'm glad we can move on now. Thank you, Psycho. Really appreciate it. Legend. So what's interesting though is like, yeah, we were kind of close. This thing I wouldn't have got. But we was getting close to, we went to the middle in the end. That was, yeah, interesting. But damn it. Right. So a radius one, right, you got a coordinate. You want to basically distance from, yeah, you get the half extent, something like that, should be good enough. How do you do dynamic shader load in Vulkan? Do you build the entire pipeline related to the shader? I just reboot the game for now. I don't have hot code reloading. Is that what you're asking for? Yeah, I got this one. It's easy peasy. Oh, I didn't do the start ratio thing on the damn. On the other one. You bugger. So 0.5 means in the middle. So 0.5 means in the middle. You want to do plus that, take that. That ought to be good enough, I think. How do we test it? So let's make that 0.2. Let's make it 0.8. Should go the other way around. Yeah. I think we can have two of those and get it working and make it better, but if we use it, you know, I have kind of over-engineered this a bit, but it's just showing the potential, I guess. Well, hot code reloading. Yeah, we don't do it yet. But how do you do it? So you have your current pipeline that you're using. But what you do is you check the file that you have on disk, and you go the shaders that is, and you check if it's changed. If it's changed, you make another shader module, and then you recompile all the pipelines for it. And then when that's done, you can then delete your old pipelines and swap it out. But if you just have one shader binary you're loading in, you could just freeze the game, delete all the pipelines, get the shader module back in, create all the pipelines. You know, it's that sort of thing. You know, but yeah, if it's just debug. But yeah, we were going to do that, but I only think we'll add it in if we really need it, because I'm not sure if we actually need it, to be honest. But if we have like a whole game we've made and we do some graphics and stuff, we might want it. Because it might be some bug, like halfway through some level or something, you might want it then. Right, so the radial one is, so you get all your bells and whistles, all your inputs. You don't have an angle on this one, therefore it's far easier. That angle really bugged us up. So this is an offset. Wait. Yeah. D norm, so you know, S norm, right, -101. D, there's no axis anymore. I guess you just min it or something like that. Or length it. It depends what you want to do, right? You've got wait, is it min or max? Maybe, you know, because this, it depends. You could length it as well. So just as a bit of a quick one, just try it out. I should really draw it out and test it out, you know. Huh? So we don't have one yet. See, I should really draw this out before we try that. Oh, so make another one. Move it to the right by one, so it's 300 if I remember correctly, 300 pixels. Radial. Right, bit wrong. I think the min max is wrong. You want to do, because that it gives you an L2 norm or something like that. Or L infinity norm, whatever it's called. Where do you want to do a length? Probably. This could be done way simpler though. I feel like, yeah, so let's draw it now. So that kind of works, but I think it's still kind of wrong. So let's draw it. So you got like your box and you're trying to do like a radial blur from the middle. Pretty close to what you would do. Nice. We get it. We're close then. So basically you want to say like, as you get, so if you have this pixel, it's like the closer it gets to the edge, and the edge is multiplied by 2. You think? Maybe that is... Maybe so. Because that's sine norm, isn't it? So it's from -1 to 1. You take the length of it. Is that really true? No, it went smaller, did it? Or did it go bigger? It's hard to tell. But yeah, so you're saying like, given this point, how close is it to like the middle and how close is it to like the edge? We tried the min, or you could do a max, you know, so if it's like, you know, it's further to the right, so we'll just use the x coordinate for instance, but the problem is you'll get like a a gradient that goes like that. I forgot what it's called. It's like L2 or L infinity norm. Whereas if you take the length, it will give you the sort of the Euclidean distance length, right? And that's like a circle, right? Which is quite fun. But so if you take the so if we have it where this is 1 and this is -1, then if you take the distance, like that should be it really. That's what we're kind of thinking. So we go from like yeah, it does look a bit odd, doesn't it? I was thinking, could I do it in less maths as well? So if we just do it with the coordinate, no, you can't really, can you? Yeah. Should we try in like a squared? Squared. See, in squared space, it looks better, doesn't it? Just when we. So we don't apply the square root, so the dot product with itself. Yeah. Should we reverse the colors around and see how different it looks? Let's do it in standard. Is that right? Yeah, that looks fine. But then swap them around the other way. Wait a minute, let's apply, make it squared then. Yeah. I could take a screenshot and be easier to see. Yeah, you get less of an area, less of a smooth gradient, that is. But then if we turn the colors the other way around, get less of the squared. See, I think the problem is partially because it's a square, isn't it? Yeah, is it because it's a rectangle, maybe? It's, yeah, it gets turned into sRGB when we output output it as final. At right the end of the shader, final color, it will do the sRGB conversion. Yeah. We need to add this thing to it as well. So let's animate it, shall we? Animating should fix all. So we'll go from absolutely nothing to all the way on. And let's see if that shows us anything. Yeah, it's definitely not correct, is it? So it goes all the way to 1. And that it should make it all red, but it doesn't. So we'll leave it squared. So you were saying times by 2, wasn't it? That time. Times by 2 just makes it... the red smaller. Should we be dividing it by 2? Oh, divide by 2. But why? So let's remove that animation. Yeah, that looks better. Although I would expect it to be more green on the edges, right? Like, I don't see a green pixel here because the bounding box would be right there. So you should see a green pixel right on the edge. But I don't think we do see a green pixel at all. But if we make it squared instead. Still not reaching the whole way. Okay, what's the other issue? The aspect ratio. Yeah. That's true. Yeah, and also when we do a length on a box, like length on a box, a diagonal isn't going to be the same as going to the right, is it? Because it's you know, you got an even box. The length to there is not the same as the length to there because it's a circle. So ideally, you wouldn't expect it to completely get rid of it. It just has to stop at the edges. So that one's perfect. Yeah, so that is literally perfect right there because it's hitting up against the edge of the bounding box. So the funny thing is, if you go all the way to the corner, you need to multiply by square root 2. Yeah. So here I don't know why this is correct. I did length squared. And then divide it by 2. So if I just divide it by 2. Wait, that's perfect. Perfect. So I just have to do the aspect ratio thing now. So you got the bounding box. Yeah, so you just need to offset this unorm thing. So your aspect ratio width divided by height. Yeah. Offset unorm. Yeah, but doesn't that not work for different we'll change the orientation and see if that works. We'll make it more apparent as well. It's definitely fixed the thing, but it's not in the middle anymore. Right, this one. Good old Snorm. Our buddy Snorm. Right, thank you. So my question is though, is like, I think if we change the box to instead be taller than wider, the aspect ratio, it works then, perfect, maybe. The other way it doesn't. Isn't that because you need to say if it's, you need an if statement, don't you? You can't just do it across one axis. Yeah, because that only does the y. Yeah, you want to say if this bigger than that. Can't use len anymore. What happens if you just made the box bigger, right? No, I thought you could just do this, right? If this is greater than that. It's one of these ways around, I keep forgetting. But I think you just do this, right? I think it's the other way around. There you go, so that will make it so the x-axis, you know, spans the whole thing. And then this one, change it the other way around. Yeah, that's perfect. See, it goes all the way against the edge, depending on which edge is the longest. There you go, that'll work. Sweet. So I was thinking, is there a better way you could do it? Multiply the length by the aspect ratio as well. What's wrong with the length then? Instead of the ifs. Ooh. Right. Yeah, because you would have turned it down into one. Hey, collector of stuff, how you doing? Alright, see how that works. Obviously, we'll right, that. No. Yeah, not quite. Um. Maybe you just do a max element or something. Maybe you say divide s max element f32 times 2, something like that, right? So you get the maxes between x and y. And just, is that gonna work? It does work, but then it ruins the offset, doesn't it? I think it worked, yeah. Yeah, I think it works, but it ruins the offset now. So you just need to offset by... What do you want min? Yeah, because... Yeah, that won't work. Yeah. Because if you have... Is there another way you can get a center position? Nah, let's keep the if statement. Screw it. That'll work. We can make it better in the future. Right, so I believe that's a good... That's a win. That's incredible. I was thinking, can I animate this as well on the other gradient? I don't know. Are you having a good coding day? Yes, it's going okay. Right. We spent bloody ages trying to get this axis working on, like, basically getting the gradient to rotate this one. But thankfully, Psycode came and saved the day. Gave me a lovely snippet of code, and also helped me correct my or basically like remind me that I'm not doing the sRGB conversion, and made this all look proper sweet. But yeah, so we're just doing gradients today, by the sounds of it. I was hoping to do more. We had more things, as you can tell in the title, but it's all a good, because we would have finished gradients at least, which is 3 things ticked off the list, when I thought it could have been 1 at some point. So let's do one more gradient. We'll stick this one above, so it's up by 240. And we're doing a distance gradient this time. This one is amazing. What is a distance gradient, you ask? Inner distance, outer distance. Yeah, so... Well, we could have do it with 4 colors. We could also just do it with, like... No, 4 colors. 2 distances, but we could also just have 1... Yeah, we'll do 2 distances. So we'll say, hey, you start at maybe like... So this could get you like a gradient border if you wanted. It'd be a bit weird, but you could do it. Appreciate the hard work, sir. Thank you. It's good to have a second monitor when you work. Self. Yeah, I actually only use a single monitor. I don't typically like multi-monitors because the one on the other side typically just goes to waste. It worked for you. Oh. Whoa. So you multiplied by the, or divided it, the length by the aspect ratio. I mean, when coding, it's nice to have someone else working hard too. Oh, I see. Like, yeah, we're working, yeah, both in some form of like, yeah, both solving hard problems. That's it. Yeah, I think that's what most people do, right? Is they come in, have someone working hard on the stream, and yeah, it's a good idea. Keeps people focused on their own stuff rather than going on YouTube, I guess. Right, so you're saying divided by, always divide. I did a multiply. And then oh, but you've done it across the x-axis. Oh. Right, let's have a look. Can that stay in there? Yes, it can. Radial. So what you're saying is just do it across the X, but then, right, so you say float 32 AR, right? It's not assault rifle, folks. Aspect ratio. And then what you're saying is, oh, you bugger. Just do divided by AR. That's what was missing, I think. I think that's what you're saying. So that definitely hits the edges there. Bam. Beam. That's good. So because that's the widest edge, that's what I'm saying. This is the wide, that's the shortest edge, right? And then if we swap the axes around, so it's this one. If I had a memory stick there, it would have just been destroyed. Yes. That would destroy my memory stick. Goodbye. Just DD is so dangerous. Oh my days. Right, so that one is still only across the x-axis. That's the problem. You need the if statement still. So when you change it. Yeah. But it was close. I thought oh, there was something new I didn't understand about aspect ratios. I was like, oh my days. You could do it branchless, but no. Okay. Yeah, no worries. No biggie. So we need, so for the distance one, we need like a start distance. What do we call it? So we can basically have like a gradient border. Pretty cool. So let's say like 10 pixels and then like, I don't know, 15, well, no, a good number, 16 pixels. And we call it inner distance and outer distance. So inner, outer. I don't know if I like these orders of things. Maybe they're fine. Distance, outer distance. Right. Sign distance field based gradients. So which means it kind of has to go the other way around. But anyway. And then this would mean so you got your distance from the edge. Where is it? Well, it's in the distance stack. We've got a stack of distances. It's legendary. So with this one, you've basically got to say there's a lerp involved, right? There's always a lerp involved when it comes to gradients. Yeah, shaders only run on the GPU. This is a custom, or this is C, compiling to run on the GPU. Like I've got my own shader compiler basically. I've spent like a year making it, a year in my spare time just making it, and it does pretty good. It runs in Vulkan only though. But yeah, this is part of the reason why we're doing this project, so we can just write a load of code that just tests it, and then I can just make it better. But yeah, another great thing as well is you can basically copy paste this code and run it on the CPU, with some adjustments when it comes to reading from textures and buffers. But yeah, that's one of the and you know, share code, all that good stuff between the CPUs and GPUs. So if you have a distance, right, what you're saying is if you're in between inner and outer, there's some smoothness going on. If you're before outer, you're fully outer color. If you're after inner, you're fully inner color. So basically, you know, you kind of have to ensure what's a good way of saying it? We've got to make sure that we've got to ensure that the distances are really, you know, we want to say, so the outer distance should be inner distance. So we basically want to like min or max one of them to the other one. So which one do we use? So the outside one, the outside of the shape, must be it must be to find the minimum between outer and inner, right? And then that will solve any problems where they're the wrong way around. And then we can just assume they're fine. So basically you want to get like probably like the difference between these two. So which one is bigger? Well, the inner distance is going to be bigger. And then when you have the difference, this is something you probably divide by in a second to get some form of t value. So I think you need to say like take away min or something like that. Yeah, it's super useful. Like the thing is, I just, you know, I don't know why no one's really done it. Like HLSL is the closest thing that people basically try and get to work with, because it's very similar to C++, but it's still not the same. And it's just good when a language is semantically the same, or as close as it can be. Even though the languages, you know, like C and C++ have very horrible semantics in places, it's just good if you have the same tool. Distant, so you kind of have, so outer is smaller, right? Outer color, so that goes first, say. It can go the other way around, but it's just easy to think about it that way. Just one GPU lang. Yeah, but then you wouldn't have Rust. Rust on the GPU. Oh, the WGLSL. See, this is the problem, is you kind of just did have just one GPU language. It was just GLSL or HLSL. And they're basically, you know, if you're programming in for OpenGL, you just have one shade and it was GLSL. Yeah, really bad. But then you went to a different platform, like DirectX, just to do HLSL. So it's got better now because you've got HLSL that kind of goes across all of them, but it's still really hacky. Put it that way. So I want to try and make this one go across multiple platforms, but I haven't done it yet. And again, part of the reason why I'm doing this project is so we port it to other platforms and then I do it. So the t value, right? So you got the difference. So that's like purely something we can divide by. So if you take the distance, right, take away the min. See, this is basically just a remap function, and guess what we have, guys? A remap function. We have the min max. Oh, maybe. No, it's not. Yeah, it's a min max. It's a remap function. That's all it is. Remap between -1 and 1. But yeah, inner distance. So what's the smallest value? Outer. Then you divide by diff. Voila. Because that, yeah, and then it obviously go bigger or smaller, but it should be fine. Right, clearly we haven't, right, I want to put this back to what it should be. Nice. Right. Clearly wrong. So what we want to do is get some coloring to tell us the problemo. No. Diff 0, 0, 0, 1. So just being the red channel, the difference is from 0 to 1, hopefully. Right, so it's always greater than 1 for some reason. Something's clearly wrong. So the distance value, so we get the distance value on the distance stack, should be fine. At that point, there's only one value on the distance stack, and it's always a 0 when we are doing some colors. HLSL is better than GLSL, especially for C++ people. GLSL is definitely very, yeah. Some people prefer GLSL, they can prefer it, but yeah. How do you decide what will be the one? Did I bugger something up? When I said core min, so outer should be the smaller. Yeah, that's fine. Inner color, inner, right. Inner, outer, inner, outer. That's what we like to see. So, all right. So, should we get the distance then and just color it via the distance, just to show that the distance works, right? Oh, what? Distance is negative, is that right? Distance is negative, of course it is. So, yeah, I think that's fine. It's meant to show red like that because it's very if we divide it by 16, you would see it. Be smooth. Well, I thought you would at least. Wait, no, this is scalar. Sorry, yeah, this is the same on every thread. It's not changing per pixel. It's yeah, it's a constant. Yeah, so we don't. Right, anyway, so you get the distance. And I think that was the issue, is the fact that it was negative. Oh my days. So it's kind of given us like some anti-aliasing in a way. It is pretty sweet. Obviously, ignore the blurs. They're bloody horrible. But, because that's the zoom tool. But if we were to increase those numbers, that was only like 6 pixels. Let's do like 32. you know, you get that nice, oh man, look at that. Oh, look at that. Let's get a nice screen grab. So I'm glad we got this far today, because we spent ages getting the Axis thing done. It's built into KDE, and I want to file a bug report with them because it's kind of crap, but it's nearly there. So if I hold the command, the Windows key down and press the plus key next to the backspace, right, just the plus key, you can zoom in and out, and it even gets captured on stream, so it's amazing. But they use linear sampling, so it just looks blurry, you can't see the actual pixels. And I want to file a bug report with them, because then we can do graphics. So you kind of like, you know, look at that. Oh, isn't that sweet? That look good. But yeah, so this is like a distance-based gradient. It's pretty cool, right? I've looked in the settings. I can't find it. Hey there, Fabricia. How you doing? I'll just call. Wait a minute, are you on my screen wrong? Oh no. It was my screen protector was damaged in the area where your name showed up, so I couldn't read it. Kevlar Britcher, welcome back. How you doing? I use Manjaro. I think this is a Kwin feature, right? Because it's the compositor, I think, that does it, right? So I think if you use Kwin as the compositor, it might be a thing you can just get a custom key command to link up to. Right, shader toy. Oh. I'm sure you don't want the idiot gradient. Nice. That's pretty sweet. You can do like a little wiper as well. Yeah, I'm not sure everyone really need this. To be honest, I'm not sure how much I really want to use these gradients anyway, but I want to just have them there. Like, this one I see could be quite useful. This one is the one I initially thought of anyway, and I was thinking let's just do the traditional ones. This one, you know, it could be useful. We just got to see, right? I might have to change it so we do some more of like start-end stuff like we've got for this one. This one, you know, I guess they can all be useful. I've not got a specific use for them. But yeah, they're good to have at least, just in the toolbox. Yeah, I think they're good just to have in the toolbox. I've just not got really a, like, we're using it for this. I think that's kind of the problem. But yeah, that's really good. So that's 3 more things ticked off the to-do list. Well, okay, it's just one thing, but there's 3 things in there, I swear. So what's next is we want to do... Wait, did I commit the changes? I did. I made changes to compiler, I fixed that, good. Anti-aliasing, as you can tell by the image we saw, there was horrible edges everywhere. But now we've got all the features in. So really, it's should be quite easy. We've got distance. We can anti-alias it easy. Bam. We want to do transforms. Like, how do we do those? And we want to do distance. Distance-based clipping, which would be pretty cool. Yeah, I showed it on my Twitter. I had like some Mickey Mouse logo that I made out of clipping shapes and like just scaled it, and you could do custom clipping. I've done it before in the past using sign distance fields, but you can even do like distance-based alpha. So you could probably like say have a smooth clipping in a way, which would be rather than a hard clip in some if you really wanted. It's weird. I don't know how useful that actually is, but it's a bit of fun. And it will be interesting to see what you can do with it. No, plus just means I've done them. Oh, right. Oh, I see. Yeah, up here. Good. Thanks, Sockham. Good catch. Yeah, so, yeah, it's just 3 more things, and then we can move on to actually optimizing this shader. So if you see here, we've got an optimization at the moment happening, but we've got whole screen rendering using compute shader. Every draw command that we add, this number always goes up. Like if we remove the optimization, yeah, we basically per pixel we go over every draw command. Each one of these guys is a draw command, and we check to see if it's inside the box. And then if it's if the pixel is inside the box for the thing it's trying to draw, if it isn't, it skips it. And that's why it ends up being as quick as it is. But if we remove that check, it runs over all of the distances for all of these per pixel, including the ones that don't do anything. And that gets really slow. To the point if I were to remove it, yeah, but it can be faster. We're gonna tile it. It's gonna be binned. So if I remove this, I don't think we'll need it when we bin these per tile. We'll get a list per tile. Yeah, it basically times it by 10. So it's 10 times quicker if you check. Yes, that's 4 ms. Horrible. But yeah, we skip it. Yeah. Well, yeah, it's not. 10, it's about like 11 times. You need culling with SDF. No two ways about it. Yeah, well, yeah, so the thing is like we need to cull. We need to cull. Yeah, like if you have a widget and it's scrolled halfway off the page, you need to cull it, right? Yeah, definitely. I just got order independent type checking working for first time. Wait, first try, something feels wrong. Yes. Yeah, definitely print out to see if you've if it's not just ended early or something. That happens a lot to me. I'm like first time and then it didn't really run the code, you know. Yeah, check your debug stuff. Gotta make it tile based. Yeah, so we'll just bin it per tile, have a bin. We'll have a little array per tile. It'll be a variable sized array somehow per tile. Sort that one out. Do I have multiple full screen passes? Yes. Currently we have a clear full screen pass that runs. Although we don't actually need it with this one running. But we are going to be doing 3D soon. Well, after we've done the UI system, we'll have 3D that will run first. So we'll probably need a clear. So that's what it's full screen in terms of whatever this resolution is, right? Which is 1280 by 960. So yeah, that's what a full screen pass looks like. The simplest one, 0.04 ms. It's about 43 microseconds. Yeah. Yeah, the aim is I want to try and get a good frame rate on 4K. I don't have a 4K monitor at the moment. I did have one temporarily, but it was terrible, so I have to send it back, and they still haven't taken it back yet. But anyway, I'll be getting that refunded, and then I'll get a 4K monitor. Hopefully get 60 FPS, and if we can get even more on my card. I've got like a £250 card. Like it's not. I got a. Oh no, don't have PayPal. I got a AMD 6600, not the XT version, just the baseline one. 28 compute units, which means that is 28 times 64 threads. So when we run our compute shaders, we can be doing that many pixels at a time. 64 gets you an 8x8 grid of pixels. So that's why a tile is going to be 8x8 and then 28 compute units running at once. I stick to order dependence in my own compiler. My concept of metaprogramming really depends on definition order. Okay. You think this is doable in OpenGL with compute, or does it require Vulkan features? No, you can do compute only in OpenGL. You even get all the you can do everything really. Yeah, if you support OpenGL 4.3, you can do compute. But yeah. See if it can run these games at these FPSs. I don't know if we're gonna have. That's 1080p. Max settings apparently. So I don't know, if we can do 4K 60, that'd be pretty good, wouldn't it? We'll try. That's the aim. We got the little profiler here, so we can try. Bum, ba-dum, bum, bum, bum. Right, I've got a jam because I've got work tomorrow, and yeah. But I was just playing Magic. But thank you so much for your help, everyone, and for coming. I'll next be streaming on Thursday, 6:30 p.m. GMT +1, same time, but on Thursday. What else? Yeah, that's about it. I'll upload the code to the GitLab for those who are subscribed. Yeah. When will I see the seas? No worries. Thank you. Oh, who made an MMO? Which guy made an MMO? Oh, Eskil Steenberg, did he? Ah, yeah, I've seen his stuff. Was he streaming? Oh, he's actually streaming. Fair play. I didn't realize that was him. The more you know. Yeah, I've seen his videos and things. Yeah. Let's give him a raid. Why doesn't he put like C in his title? That would be helpful. Right. Have a good one, guys. I'll see you all in the future one. Have a good night, and yeah, in a bit. Bye.